Hey guys, my name is Varun and today I'll be presenting to you MIP mapping in OpenGL using C++. So first of all, going through the project structure, everything is dynamic and we even have relative paths instead of absolute paths now. So that's a good addition. So if you download the project now, you can just directly run the project and you can find the project on my GitHub. So moving on, what we are doing for this project or this assignment is we're creating a simple plane using vertices, and we can change the plane size and keeping it a 5 by 5 plane with the UVs just half of the plane. So plane size. Next up we have our render scene. Before that we have prepare objects, in which you can see that we're loading the texture. We're loading the same texture that is the checkerboard PNG, which I will show to you. We are loading this image in different styles. Which styles? So uh, this code was referred to from Learn OpenGL tag MIP Map. So yeah, essentially for choices 1 and 2, we are using the nearest interpolation for min and max filtering for the magnifying filter, and for choice 1, we are not generating any MIP maps, right? For choice 2, we are generating MIP maps. For choice 3, we are just using a linear MIP map nearest, so linear nearest and a linear, and we are generating MIP maps. And for choice 4, we are using a linear and linear, and then we are also using a MIP map. So that's the main code in the texture.cpp that is changed. So moving on, we have the main.cpp. So essentially, based on the parameters, these textures are loaded into the memory, and I'm using these textures in the render scene. So as you can see in the loop, I'm just drawing the plane with a certain offset, and then I'm just using the texture that I want to use, right? So we are going to start with a simple texture that has no MIP maps. Then we are going to go to the texture from left to right. We are going to nearest MIP map. Then we're going to linear MIP map nearest, and then linear MIP map linear. So I'll run the code. So essentially, we'll have a scene like this where we have four planes. First plane, as you can see, I'll increase the lighting. So the first plane, as you can see, it doesn't have MIP map, so I magnify the whole thing, and if I go here, so you can see that the texture remains constant even in the far distance. So essentially, in these corners or these places, the texture remains constant, right? Next up, we have the nearest MIP mapping. I mean, not MIP mapping, but the nearest interpolation. So you can see that as we go in the distance or even at the horizon line, we can see that the texture is very bad, and we are getting a lot of aliasing as well as artifacts. So even in the closer scenes, you can see that there is aliasing. Next up, we are using linear with nearest. So for the near plane or the magnifying filter, we're using linear. So you can see that the artifacts have been more or less eliminated, and in the further distance, or you could say farther away from the camera, we still have some artifacts, but they are not as prominent as the previous one. Moving on to the last one, this is by far the best one. So you can see that all the artifacts in the closeness or in the magnified area are gone, and moreover in the minified area or area a particular distance from the camera, we have good fall off and the texture is getting smaller towards the end. So that's the concept of MIP maps. So you might ask where they are used. Well, they're used in many places, and one of the most important use cases for them would be games or computer games, in which after a particular object goes out of the field of view, or a particular object is diminished or very small in the scene, you don't necessarily need to render the full quality. So as you can see that we get further away from the camera or further away from the plane, so we are getting to see some noise in the middle two ones that we're using nearest and a MIP map, and we're starting to get some noise in the rightmost. But the leftmost one, again, the number of pixels on the screen that it's covering is very less, but yeah, there's no noise in it. As we keep going further, you can see that the leftmost or the rightmost one changes and the leftmost one doesn't change. So if you look carefully, there's a switch in the texture. So it's switching out the texture based on the distance from the viewing camera, and that helps save the cost of rendering and it helps save a lot of memory. So yeah, that was the concept of MIP mapping. If you want to view this in an orthographic view, you also do that. So yeah, as you can see that near the camera, we are getting a good follow because there is no MIP map, and away from the camera we are also getting a good follow, but in the middle it's pretty sharp. So these are the things, and that was the concept of MIP maps. Thank you very much for watching and see you next time.